In this video, let's have a look at area of triangles, and these are triangles that are now not right angled. So this applies for any triangle. It would also apply to right angled triangles as well. So just a note here on labeling triangles. We use capital letters to represent angles, and you can write that inside or outside of the triangle. And lowercase letters to represent side length. So if this is capital letter C here, we're going to use lowercase letter c on the side opposite that angle. Same goes then for labeling the others. We often use A, B and C. So side A is going to be opposite angle A, lowercase for the sides, capital letters for the angles. And in this particular concept, we're interested in included angles. And what does that mean? So if we have two sides and an included angle, we can find the area using this particular formula. So just summarizing what included angle means, if we're interested in finding angle A here, that's the included angle between the two sides that make that angle. So look at the sides that come together to give the point at A, that is side C and side B. They're the sides that we need to use if we were solving for angle A. Having a look at this example though, we're using capital letter C. So that would be this angle over here, C, and then that's the included angle between which two sides? The ones that come to make angle C. So that's side A and B. So in this case, B and A there, and they're the sides that you use in the formula. Let's do an example now, finding the area of this triangle. So we've got draw a triangle on your page, label some of the sides with these dimensions, and let's try and find the area. So we have two sides and an included angle. So just to confirm what that is, so here's our angle here, clearly not to scale, that looks more like 90 degrees, and the 16 and the 9 are either side of that, so they're the included angle. So let's write out the formula each time that we do this. So we're solving for area is equal to half AB sine C. So let's label our triangle. Let's label the angle C. If you like, when you're still learning this, you might find it helpful to label all the sides and all the angles. So let's just do that once. A, B and C. Label each of the sides. So little letter C across from angle C. This is B because it's across from angle B, and the last one therefore must be A. Now we can substitute them into our formula here. Capital A for area is equal to a half times by A, which is 9, times by B, which is 16, times by sine of C, and that's our angle of 35. Making sure your calculator is in degrees, and the answer that you would get for that is 41.298 meters squared. We usually go to 1 or 2 decimal places. I just happen to have gone to 3 this time round. Finding a side now. So let's use a triangle, and this time round we're given the area. So we're given one of the other values in that formula, and we have to rearrange to find the side. So label our triangle. Well, we're going to label it, but also be aware of the formula that we need. Half AB sine of C. So let's call the angle C, because that's what we're used to dealing with. And then the other two sides we can call an A and B. It doesn't matter which one you have as A and B. Let's substitute those values into the formula and see where we can go from there. So first of all, though, we're actually told that the area is 737. So we can put that in place of the area. Let's leave the other values there. As we know, when values are sitting next to each other, those variables, there's a multiply in between. You can't see it, but it's implied that you multiply things together. Multiplied by x with a curves, not the straight ones that look like a multiply sign. Times by B, now we have 120, and times by sine of C, which is the angle is 17. Now we need to rearrange to get x by itself. We tend to put x on the left. So let's do a little bit of tidying up here. The top row would be, the numerical part of that is 120 sine of 17. You might also change that half to over 2. And write it like that. And now we need to rearrange. So it's being divided by 2, so we need to multiply by 2 to undo that divide there. So 2 times by 737. And then x is being multiplied by those other two numbers, so let's divide through by those numbers. Notice that I put x in brackets. Perhaps I could have put x at the beginning, just so that it wasn't confused with all of the other numbers involved there. And then making sure your calculator's in degrees, solving for x, we have approximately 42, and the units of that would be kilometres. And just one last little note here, this might help with some of the slightly harder problems. If you get given a triangle where you have two angles but not the third one, and then you're asked to find the area of the triangle. So what we've learned so far is that to find the area, you need the included angle. So we would have side 12 here and side 10. Where's their included angle? Well, it's the one that's left over, it's in here. So how could you work out the size of that angle to then use it in the formula? What fact do we have to remember about triangles and their angles, their degrees? That there's 180 degrees in a triangle. So that means we can have 180 subtract off those other two angles, and that'll help us find that third one. So if we have 85 plus 35, what does that give us? 120 degrees. So therefore we're left over with 180, subtract 120, 60 degrees there. So that would be 60 degrees for that included angle, and now you can use the formula to find the area of that triangle. There's some problems to do now. Thanks for joining me.